Innovation and speed, the new era of defense technology.
One-on-one with Mars, the global AI starts now. Good day, dear viewers. We present to you the next edition on One-on-One. Our guest, Rob Balloch, the Chief Growth Officer at Mars.
All right, it's a pleasure to be with you this afternoon.
Thank you so much. Thank you for your taking time. How do Mars AI-enabled unmanned and autonomous systems address current security challenges, and what advantage do they offer?
As we're all seeing with the recent events, especially across Europe and elsewhere on the globe at the moment, we're fighting an asymmetric war, whether it's in Ukraine or whether it's in Yemen, or when we look at the maneuvers by some of the nations in APEC, we're facing a type of warfare we haven't really seen before. It's evolving very rapidly. The threat changes on an ever-increasing basis, and we need to adapt much quicker and much faster to allow us to detect, to classify, and to ultimately defeat these new asymmetric threats, whether they're in the underwater, on the surface, or in the air.
And what are the key features that differentiate Mars solutions for critical infrastructure and protection from other available technologies?
One of the key features about NIDAR is we're a multi-dimensional tool. So we can be used for protection against asymmetric air threats, counter-drone. We can also be used to protect the perimeters of critical infrastructure. And we're able to protect the wider perimeter outside of that against potential land attacks or maritime attacks if I'm looking at a waterfront type environment. We're also what we call sensor agnostic. So where the end users have already invested in significant legacy type systems, we can integrate those legacy systems into a single situational awareness platform with the new technology and the new effectors to give the operator that ability to have a single picture to see all these different threats and all these different dimensions and defeat them in a structured manner.
What is this NIDAR? What are the opportunities?
There's two sides to the new project. One of those is where if we think of the protection of an asset as a bubble around that asset, and depending on the size of the nation or the size of area I'm looking to protect, we can mesh those bubbles together into a myriad of different sizes and shapes, depending on the sensors and effectors I have available to me. And we can mesh those all into one overall larger bubble that can operate from a central platform and can help to support the different operators, whether they're in expeditionary systems at the front line, or whether they're protecting an oil refinery, or whether they're protecting government buildings or a port. They're all sharing the same information in real time together and can all help to support each other.
And how important are integrated systems in reducing security risk across maritime and land and air domains?
They're absolutely vital because in every nation we have different agencies responsible for their piece of the puzzle, whether it's air defense, whether it's border force, whether it's the Ministry of Interior, or whether it's the Coast Guard or the Navy. They all have their own assets and their own infrastructure, but in most cases, no one talks to each other. There isn't much information sharing going on. And sometimes that's complicated because one ministry will have different sensors to the other ministry. Using NIDAR, we're able to help integrate those legacy systems into that one platform, taking information from them whilst at the same time feeding that information back so that everyone is on the same playing field. Everyone has the same access to the information, and everyone can support each other in that decision process. The second part of it is when you mentioned AI at the beginning, artificial intelligence, and we're seeing the world in the digital sphere evolve at a very, very fast rate. And the only way we're able to keep up with the adversary is if we're doing the same thing as they're doing, but faster and better. And we can't build sensors and effectors fast enough. So the only thing we can really do is to be able to take all that information, analyze that information, make a decision out of that information in as quick a way as we possibly can, and allow the operator to reduce the decision cycle. So detect, classify, defeat.
And what impact do unmanned maritime systems and early warning solutions have on operational effectiveness?
The key thing there, and again, if we look at some of the ongoing theatres of activity that currently exist, within 10 to 15 kilometres of the front lines now, there is no one. It's all unmanned, whether it's unmanned ground vehicles or unmanned area vehicles. And the escalating war that we're in is we're looking to find countermeasures to defeat those asymmetric threats. And where NIDAR comes into that is allows us to put intelligence onto unmanned assets where we can use NIDAR to autonomously instruct and guide that asset, whether it be a tracked UGV or a surveillance drone, without having a pilot to operate it, because pilots are in short supply. They're expensive to train, and we don't want to just to deploy one asset, we want to deploy hundreds of assets. So if we allow AI to be the brain, we can fill the ground or fill the sea or fill the sky with these unmanned assets that are all talking to each other, they're all meshed together, allowing us to build that picture of activity that allows us to defeat the other side.
How do AI-driven command and the control platforms enhance a decision-making process?
It's all about the decision cycle, and in conventional warfare, we have what we call the swivel chair analogy, where someone's looking at a radar screen, they get a detection, they pass a track to someone looking at a camera, that person passes a track to someone looking at an effector. And when you go through that traditional CONOP chain of events, the decision cycle between detection and defeat can be 50 to 60 seconds. If we use AI to sort that issue out, we can shut that decision cycle down to less than 10 seconds. So allow AI to be the brain that helps us to do that.
What role do international partnership and cooperation with the government authorities play in Mars technology development strategy?
The key here is no one government's the same. I'm working very closely with the United Kingdom and the Department of Business and Trade and the MOD, and the facilities that the UK government can extend to international partners. We can work together to assess the requirements of each individual government in its own way, work to understand what their existing legacy capabilities are, work to identify where the gaps might be and what they're looking to achieve. And we can work with them, with our UK partners, to build a tool set that allows them to both enable and control what they already have, invest and work within their criteria of what they want to choose in new technologies to ultimately bring together a complete system that fits their requirements. And the international collaboration is important because we need to work with with our British partners, we need to work with European partners, we need to work with American partners. Everyone has a role to play, and how we can bring all these different technologies together to fill the needs. And in Azerbaijan is a classic example of the offshore oil and gas infrastructure, the government infrastructure. You have a significant maritime coastline as well as the land borders. And it's how we can work with Azerbaijan, for example, to help understand what their requirements are. And take Lego bricks as a good analogy. Each different partner can supply a different size Lego brick. And working together with Azerbaijan authorities, we can build out a great model from that bundle of Lego bricks that allows us to create a system.
Now, so famous and so important for the AI technology. What is the future plan for the Mars Agency?
The future plans is being aware, again, retaining that flexibility where today's provider of an electronic countermeasure system may not be the same provider in a couple of years' time. So where we may use an American piece of technology to do one thing today, I may need to be able to marry that American technology to something developed in Azerbaijan, for example. So having an open architecture approach. So many historical companies operating in this sphere, they work on a closed architecture that doesn't like to open itself to working with multiple different partners and different agencies. Here at Mars, within NIDAR, we operate an open agnostic approach where we want to help people develop, we want to help people to grow, enhance national and domestic capability, whilst at the same time keeping up with that AI race as you described earlier.
And finally, in light of ongoing changes in the global defense industry, what are the Mars short and the medium-term priorities?
Short and medium-term priorities, that is a very good discussion. I guess the biggest factor that, if we focus on air defence for a moment, the advent and the rapid proliferation, is the right word, of fibre-optic drones. Whereas even just a year ago, we were deploying electronic countermeasures to jammers to jam GPS and control signal feeds to unmanned systems. Fibre optics makes that much more difficult, and we've gone from 10 kilometres to, I just saw last week, a spool being captured with a 50-kilometre spool on it. It completely changes the way we have to look at effectors. We have to think about it, to be able to detect and classify these targets at much longer ranges, and having effectors that are able to either kinetically defeat that, either by proximity kill or hit to kill, is the only way to defeat the fibre.
Thank you for your taking time and insight, Mr. Balloch.
Thank you, Nat. It's been a pleasure talking to you. Thank you.
So much.